In the real world, things often work in pairs. The more time you spend practicing a sport, the better you become. The faster a car drives, the more gas it uses. These linked amounts are called quantities. To describe the relationship between them, we need to use at least two different variables. One variable will track the effort, and the other will track the result. When we use two variables, we have to decide which one controls the other. The independent variable, usually called x, is the quantity you can choose, or the one that changes freely. The dependent variable, usually called y, is the one that is calculated after the x is chosen. Its value depends on x. Think of the dependent variable as the result and the independent variable as the cause. Let's practice identifying them. Imagine you want to rent a bike. The scenario is the total cost C depends on the number of hours H. Which one is independent? The hours H, because you choose how long to rent the bike. Which one is dependent? The total cost C, because the cost is determined by the hours you chose. There are four powerful ways to represent the relationship between any two quantities. You can state it in words, which is how the problem starts. You can show it in a table of input and output data. You can express it as an equation, which is the algebraic rule. And finally, you can show it visually on a graph plotted on a coordinate plane. The relationship in words is your starting line. It clearly explains the rule. For example, the sentence, "The number of wheels, W, is 4 times the number of cars, C," tells you exactly how the two variables are connected. You need to read this description carefully to translate it accurately into the math rule. The second way to represent the relationship is with a table. A table organizes your data into pairs. The independent variable, x, usually goes in the first column, and its corresponding dependent variable, y, goes in the second. The table helps you look for the pattern between the input numbers and the output numbers. Let's look at a table where the rule is simple addition, y equals x plus 2. When the independent variable x is 1, the dependent variable y is 3. When x is 2, y is 4. You can clearly see the pattern. Every number in the y column is exactly 2 more than the number in the x column. Now for a multiplication rule. Y equals 5x. When the independent variable x is 1, y is 5. When x is 2, y is 10. The table shows that every value of y is 5 times the value of x. Tables are excellent tools for finding these underlying mathematical patterns. The third, and most formal, method is writing the relationship as an equation. The equation is the algebraic rule that works for every single pair of numbers in the relationship. It always sets the dependent variable equal to the expression involving the independent variable. For our car example, the equation is W equals 4C. Let's practice writing an equation from a word problem. The total cost C is $5 plus $2 times the number of items I. The total cost C is dependent, so it's on the left. The rule on the right is the constant, 5, plus the variable part, 2i. The final equation is C equals 5 plus 2i. You can also write an equation just by looking at the table. If a table shows that for 1 hour of work, the pay is $8, for 2 hours, the pay is $16, and for 3 hours, the pay is $24. The rule is that the pay is always 8 times the number of hours. If P is the pay and H is the hours, the equation is P equals 8H. The final way to represent a relationship is on a graph using the coordinate plane. You take the data pairs, or the ordered pairs from your table, and plot them as points. The independent variable, x, is plotted along the horizontal axis, and the dependent variable, y, is plotted along the vertical axis. For the equation y equals 3x, we can plot the points. When x is 1, y is 3. That's the point, parentheses, 1, 3, close parentheses. When x is 2, y is 6. When x is 3, y is 9. Plotting these points on the graph shows the relationship visually, usually forming a straight line in 6th grade. The graph tells you a lot about the relationship, especially the rate of change. For the equation y equals 3x, the rate of change is 3. This is shown by the steepness of the line. For every 1 unit you move to the right on the x-axis, the line goes up 3 units on the y-axis. That rate of change is the number, or coefficient, that multiplies the independent variable. Interpreting real-world equations is a crucial skill. If you see d equals 65t, you can interpret it completely. D is the dependent variable, distance, and t is the independent variable, time in hours. The number 65 is the rate. It means that the distance increases by 65 miles for every single hour that passes. Interpreting tables can reveal starting values. If a table shows that when hours h are 1, the pay is 11, and when h is 2, the pay is 12, the rate of change is only 1. But to get from 1 to 11, you must add 10. The 10 is the starting value. This means the equation is P equals h plus 10. You must always account for a starting amount or constant. To create a table or graph, you must first generate ordered pairs. Given the rule y equals 2x plus 1, if we choose an input x of 4, we substitute 4 into the rule. 2 times 4 is 8, plus 1 is 9. So the output y is 9. The ordered pair is parentheses 4, 9, close parentheses. Let's write a two-step equation for a gym membership. There is a $30 sign-up fee plus $15 per month, M. The total cost, C, is dependent. The fee, $30, is the constant starting value. The monthly cost is the variable part, 15M. The equation is C equals 15M plus 30. You can compare two relationships just by looking at their equations. If relationship A is y equals 2x and relationship B is y equals x plus 5, which one grows faster? The rate of growth is the coefficient of x. Relationship A has a rate of 2 and B has a rate of 1. Relationship A grows twice as fast, even though B starts with a higher y value. Understanding relationships between two quantities is fundamental to algebra. You now have 4 ways to represent that relationship: words, a table, an equation, and a graph. Always start by identifying your independent and dependent variables, and then use the correct algebraic rule to connect them.